Hi everyone, I'm Laila again. Today we're gonna talk about a really interesting subject in computer science, Mutex handling multiple tasks. This presentation and this report is done by me, Laila Salman, for Dr. Hassan Zakaria Haj Hamad. First of all, let's talk about the aims of this presentation. Define a Mutex class, Mutex role in synchronization, how Mutex prevents race condition, Mutex advantages, simulate example of Mutex, show the differences between Mutex, semaphore, and spinlock, show a programming code that explains the role of Mutex, possible errors using Mutex. First of all, let's define a mutex. In computer science, a lock or mutex from mutual exclusion is a synchronization primitive that prevents state from being modified or accessed by multiple threads of execution at once. Lock enforce mutual exclusion concurrency control policies, and with a variety of possible methods, there exist multiple unique implementations for different applications. And a multi-threaded program, a mutex is a mechanism used to ensure that multiple concurrent threads do not try to execute a critical section of code simultaneously. Mutex and programming, or Mutex class. The Mutex class is a synchronization primitive that can be used to protect shared data from being simultaneously accessed by multiple threads. Mutex offers exclusive, non-recursive ownership semantics. A calling thread owns the mutex from the time that it successfully calls either lock or try-lock until it calls unlock. When a thread owns the mutex, all other threads will block for calls to lock or receive a false return value if they attempt to claim ownership of the mutex. A calling thread must not own the mutex prior to calling lock or try-lock. Mutex role and synchronization. A mutex plays a critical role in synchronization by ensuring that only one thread at a time can access a shared resource or critical section of code. In multi-threaded environments, when multiple threads attempt to read or write shared data concurrently, it can lead to inconsistent results or race conditions. The mutex acts as a locking mechanism. A thread must acquire the mutex before entering the critical section and release it afterward. This guarantees exclusive access, preventing other threads from entering the protected section until the mutex is released. Now, how mutex prevents race condition? A race condition occurs when two or more threads access and modify shared data simultaneously, and the program's behavior depends on the timing, of those accesses. This can lead to unpredictable outcomes such as incorrect values or corrupted data. A mutex prevents race conditions by acting as a lock that must be acquired before entering a critical section, the part of code that accesses shared resources. Now let's talk a little bit about mutex advantages. Mutex is to create a barrier that prevents two different threads from accessing a resource simultaneously. This prevents resources from being unavailable when another thread needs them. Mutex is that it can help with code reliability, resources accessed by thread can become unavailable if the CPU's memory management fails by preventing access to a resource at this time. The system can recover from any errors that cause a failure in the memory management and still have the resource available, and Mutex helps here. Well, this photo um, give us a look on how Mutex is working. Here in the Mutex, here's two threads. Thread 2 asks the Mutex for a process, wants to make a practical thing in the CPU. So the Mutex here in step 2 looked the looked the processing unit for thread 2, and nothing can enter here. We can notice here that thread 1 trying to get locked, but here the Mutex is locked. And step 4, thread 1 is in sleep condition until the step 2 runs critical code until the thread 2 finished. Thread 1 will go again and ask for a lock. Now let's have a simulated example. Imagine office with one key hanging outside. If an employee wants to use the bathroom, they must first take the key, which gives them exclusive access. While that person is inside, no one else can enter because the key is no longer available. Somebody is using it. Once they finish and return the key, the next person in line can use the bathroom. This scenario represents mutual exclusion in action. The bathroom is the shared resource, critical section. The key is the Mutex. Only one person or thread can hold the key or the Mutex at a time. Others must wait, or as we said here, sleep until the key is released before proceeding. This analogy clearly illustrates how Mutex ensures that only one thread can access a shared resource at a time, effectively preventing risk conditions and maintaining orderly access. Now, let's talk about the differences between Mutex, spinlocks, and semaphore. First, let's have a look on Mutex versus spinlocks. Mutex performance generally slower from spinlocks. Spinlocks is much faster than Mutex. Mutex have a low CPU usage while spinlocks have high CPU usage. What about fairness and priority? Mutex supports fairness and priorities, while spinlocks doesn't support fairness and priorities. Complexity and overhead. Mutex bigger complexity and overhead because complexity have a very added features too much, while spinlocks low overhead, low complexity, just shared variable, which means that spinlocks is depending on variables. Now, Mutex versus semaphore. Mutex is an object, while semaphore is an integer. Look here, semaphore is an integer, Mutex is an object, and spinlocks is a variable. We have to notice this. Then, here Mutex works upon the locking mechanism. Semaphore uses signaling mechanism. Mutex operations on lock and unlock. Semaphore wait or signal. Mutex doesn't have any subtypes. Semaphore have a counting semaphore or a binary semaphore. A Mutex can only be modified by the process that requesting or releasing a resource. Semaphore work with two automatic operations, wait or signal, which can modify it. If the Mutex is locked, then the process needs to wait until the process queue, and Mutex can only be accessed once the lock is released. If the process needs a resource and no resources is free, so the process needs to perform a wait operation until the semaphore value is greater than 0. Let's have a look about how Mutex affects the codes and how it affects um, the output of the code. Here we have the code. The first code is we're not using Mutex in. We have a variable sum equals 0. We can notice here that we are not using synchronization in this. There is a thread and the thread is starting, joining. We can see here joining, which means that we will have a summation between 1 million here and 1 million here. Okay, we can notice that it's a wrong answer. The answer is not supposed to be like this. This happens because the threads or the multitasking is not so good. The synchronization, there is no synchronization. There is no Mutex. So here we have a problem because we're not using Mutex. With Mutex, we can notice here that we added a line 3 public static synchronized void increment sum. We put the variable in this class, or in this method, sorry. We put it here with a synchronized, so it will make it, I don't know how to say, the task will happen alone. Every thread will be alone, then the other thread will be after. So here the summation between 1 million here and 1 million here is 2 million. So here is the right answer. This is the right answer because we used Mutex, because it synchronized the summation process. At last, we gonna talk about possible errors while using Mutex, or the disadvantages. Mutex cannot be locked or unlocked by any context other than the context that acquired it. Typical implementations can result in busy wait states that waste CPU time. If one thread acquires a lock, goes to sleep, or becomes preemptive, the other thread may get stuck farther. This can lead to hunger. In the critical section, he should only allow one thread at a time. That, that's all for today. Thank you for listening. Goodbye.